So far we have looked at elements of the same type in series or parallel. That is, we considered series combinations of resistors or series combinations of voltage sources and so on. But now what we'll look at is series or parallel combinations of dissimilar elements. Now, we will not do this for every combination, but we'll do it for a few that have some interesting properties. Okay. So first let's look at series combination of an element and a current source. That is, we can have any element. It could be a resistor, inductor, voltage source. Okay. And in series with that, we have a certain current I. Now, this is the combination I am considering. So clearly, if you connect this up to some circuit, we know that because of Kirchhoff's current law here, the current that is flowing through the whole circuit like this has to be equal to I. So this means that the series combination of any element and a current source is exactly equivalent to a current source. Okay. So if this current source has a value I, then obviously it means that a current I will be flowing from here to there, and that's independent of what is the voltage across this current source. Similarly, it will be independent of what is the voltage across this whole combination. Okay, because the voltage across the whole combination is nothing but the voltage across the current source, which can be anything, plus the voltage across this element. So the result is also a current source which forces a current I to flow in this direction regardless of the voltage across it. Okay. So the series combination of a current source and any element, including a voltage source, is a current source. Okay. So this means that if you have a voltage source and a current source in series, okay, so let's say this has some value V naught and this has some value I naught, the whole thing is equivalent to a current source. This is a perfectly legal connection. The voltage across the current source can be anything. The current through the voltage source will happen to be I naught. Similarly, we will consider a parallel combination of a voltage source and an element. Let's say this voltage source has a value V naught, and we can connect any element across it. We know that across this we will have a voltage equals V naught, and it will be regardless of what current is flowing through it, because the current through the voltage source can be anything, and this current is nothing but the current through the voltage source and the current through the element, which can also be anything. Okay. So the parallel combination of a voltage source and an element is just equivalent to the same voltage source. Okay, V naught. So this element can be anything. It can be a resistor, it can be an inductor, it can be a capacitor. It can be a resistor, it can be a capacitor, it can be a current source. Okay. So the parallel combination is just equivalent to a voltage source.